I'm Carlito Dino Rivera.
Go.
To begin with, we have an introduction regarding traffic lights. So the first traffic light was invented in 1868 by a railroad engineer. So the idea of the traffic light is to signal vehicles, trains, and pedestrians in the crossroads, railroads, intersections. So the first traffic light was actually a gas-lit traffic light, but since it is a gas-lit traffic light, it causes fire. So due to the evolution of technology, traffic lights or traffic signaling system also evolves to electronic and now to digital and automated. Here are the following objectives of this study. One is to be able to construct digital traffic light by applying the concepts learned in this course. Two, to develop the knowledge and ability of the students with regards to integrated circuits, especially constructing, analyzing, and troubleshooting a circuit. 3. To verify the theories, principles introduced regarding the different logic gates and combinatorial circuit. 4. To be familiarized with the pin configuration of different integrated circuits that is used to build the design circuit. So the design or the project started with a simulation from Multisim. So we first simulated our design or circuit that we want to build. So here we have decoders, registers, and combinatorial circuits and integrated circuits. So overall, there are 14 integrated circuits used, 3 7-segment displays, and light emitting diodes.
So here are the materials that we use in creating our prototype. First is the 555 timer, the 7404 NOT hex inverter, the 7408 AND gate, the 7432 OR gate, the 7447 BCD to 7 segment, the 7490 decade counter, the 7473 dual JK flip-flop, the 74194 universal shift register, the 7 segment LED display, breadboard, resistors, capacitor, LED, and slide switch. So here how the traffic light works. For the green light, it has 7 seconds. For the yellow light, it has 3 seconds, and for the red light, it has also 7 seconds. So there are 4 lanes available, the north, east, south, and west lane. For the north lane, if the first signal is red, the next signal is yellow. If the first signal is yellow, the next signal is green. If the first signal is green, the next signal is yellow. Then for the east lane, if the first signal is green, the next signal will be yellow. If the next signal is yellow, the next signal is red. If the first signal is red, the next signal is yellow. For the south lane, if the first signal is red, the next signal is yellow. If the first signal is yellow, the next signal is green. And if the first signal is green, the next signal is yellow. And last, the west lane, if the first signal is green, the next signal is yellow. If the first signal is yellow, the next signal is is red. If the first signal is red, the next signal is yellow. So here is the truth table that we get in making our prototype. This is very important because this is where we will get the input and output of our prototype. We will base our input in the truth table so we can know if our output will be correct or it's not.
So here is a shot of one of our trials for our circuit. You can see that when this LED is, this 7-segment display is on, our north and south lights are red and our east and west lights are green. So this indicates the red timer for the north and south lanes. Then this is the counter for our yellow signals for all of the lanes, and this is the green signal timer for the north and west lanes.
For the analysis, the project is tested to ensure that it functions correctly. The lanes are named as north, east, south, and west. This corresponds to the lanes of a 4-way intersection. On normal operations, the north and south lane will have green and red signal simultaneously, same with east and west lanes. The time intervals for each signal are as follows: 7 seconds for green and red, and 3 seconds for yellow. Table 1 shows the operation of the systems. For our conclusion, based on the objectives that we set in making this prototype, we can now say that it has been all accomplished all the objectives that we supposed to do. Not only the prototype itself, but we satisfied the expectation that we set in making this project. Also, we were able to get the desired output that we want in this prototype. In making the traffic light prototype, we implement all the theories and proper application. We also used a variable time circuit. Lastly, we used our knowledge that we learned in the previous 6 experiments that we have. All the members of the group were able to familiarize the different pin configurations of the different types of ICs that we used in making this prototype. That is all. Thank you and God bless.